Welcome. This video is just an example of visually what I mean by spread of data. So suppose if we say we created a bunch of dot plots for data, and if we traced a curve over them, the curves looked basically like these. These are all bell curves, and we have a very tall one here and a shorter one here. Let's go ahead and label these. I'm going to label this one A, this middle one B, and this tall one C. And now let's remember what standard deviation is, and it is a measure of spread. So which one of these looks like it's the most spread out? So C is not quite it. C is pinched in closest together. But if you notice, A looks like we'd have values all the way here, where these other ones kind of already are done by that point. By the time we get up to this tail, say on this side, there's going to be nothing left, or almost nothing left. So A is definitely the most spread. Next, which one is the least spread out? Well, that's clearly C. C has been squished in from either side, and that basically made this peak go up here. Now, we have not discussed probability distributions in this class yet, but that is right around the corner. Each of these curves, A, B, and C, are all, we'd say, normally distributed. And as a probability distribution, they have to have the same area under this curve. So, of course, if we pushed one in, it would grow taller to accommodate everything that has to remain inside of it. And if we pull it out, it would clearly grow shorter. So that aside, let's finally finish this problem, that is label these in order, an ascending order based on standard deviation. So we want to go from smallest to largest. And remember, standard deviation, we can denote that with a sigma, the Greek letter sigma. So smallest standard deviation, that's the standard deviation of C. And that's definitely smaller than the standard deviation of B, which is smaller than the standard deviation of A.